Okay, I want to pick back up in lesson 46 and go through these last two examples with you so you can see a little bit about how they're done. And I'm sure we'll have to talk about some of these in class as well. So example 3. A conical container has a height of 9 centimeters and a diameter of 6 centimeters. It is leaking water at the rate of 1 cubic centimeter per minute. Find the rate at which the water level H is changing when H equals 3 centimeters. So, first of all, I want to draw a picture like I did in the others. It's a conical container. So I'm going to be drawing a cone. And since we're talking about a cone holding water and leaking water, I'm drawing an upside down cone. Now, as we look at the cone, it says it has a height of 9 centimeters. And when it talks about height, that goes straight up the middle. So I'm going to label my height as 9 centimeters and a diameter of 6 centimeters. Keeping in mind the diameter goes all the way across the circle. It is leaking water at a rate of 1 cubic centimeter per minute. So notice there is the word rate, and it's leaking water. So we need to figure out, that's a rate, so we know that's a derivative, d something over dt. What is it that's changing? And the hint is in the label. It says it's 1 cubic centimeter per minute. So what do we have that's labeled cubic? And that is volume. So the water is changing. The water's volume is changing at 1 cubic centimeter per minute. So for volume, I'm going to say dV over dt. And it's 1 cubic centimeter per minute. Now the other keyword, it says it's leaking water. And so if it's leaking water, that is a negative change or a decrease. So that's going to be a negative 1. It then continues to say, find the rate at which the water level H is changing when H equals 3 centimeters. So find the rate at which H is changing, which means it's asking me to find dH dt, and it's asking me to find that when H equals 3 centimeters. Okay, so if we are looking at this picture, find the rate at which the water level H is changing. So we have some water level. I'm going to kind of try and draw in. Okay, so we're trying to figure out where that, when that H is 3, how that water level is changing. So, right now, notice, talking volume and talking height. And we have a cone. What formula ties volume and height and a cone together? And this is where you need to know the volume of a cone. And if you don't, Google is always great, or it's earlier in your notes. And so the volume of a cone is V equals 1/3 pi r squared H. Now, the one thing, we didn't get to this with our two examples in class, is that you'll notice this formula is V equals, but then it has two variables within it. And we need to get this condensed so that we just have one variable within. And so what I want to do is I want to somehow connect my R and my H. So height being, or H being height and R being radius. So we're going to use similar triangles right here. And I don't know if you guys can see where I'm tracing, but the height and radius of this cone make a triangle. And I'm going to try and draw it right here. And so if you think about this little triangle I just drew being this big triangle right here, it has a height of 9. The diameter was 6. Then it has a radius of 3. And then what we need to think about, so that's a right triangle here, this height right here is, or this, the water level, I'm going to represent it in here, inside. And we don't know what the radius is when the water level is down here, so I'm going to use R. And we also don't have a height. I know they want us to find when h is 3 later, but we don't actually have a height. And so, 9 is the whole thing, but from here, from that middle line down, I'm just going to call h, because we can't use that h equals 3 till we get to the end. So if we do our similar triangles like we did in the previous example, let's see, I'm trying to look at how we did it. So we did big to small. So if I do big to small, 9 from the big pairs with h from the small, because the height of 9 to the height of h. And then 3 from the big pairs with r from the small. And what I'm using this to do is I'm trying to get a connection between r and h. They talk about give me an h and dh dt, but they never give me an r. And so what I'm going to do is I'm going to solve this proportion for r, so I can then substitute it in over here. So to solve this proportion, I'm going to use cross products. 9 times r equals 3 times h. So 9r equals 3h. If I solve that for r, dividing by 9, so 3 divided by 9 is 1/3, so 1/3 h, or h over 3. And as I said, what I'm going to do is I'm going to take that up to my volume formula, and I'm going to use that to plug in r. I'm trying to get this so this is all in terms of h, and so that when we have to take the derivative, we don't have to have multiple variables in a product rule. So let's clean this up. I'm going to substitute in 1/3 times pi. Now in for r, I'm putting h over 3. So it's going to be h over 3 squared, and then times another h. Again, cleaning it up. If we talk numbers, there's a 1/3 and there's a pi. We also have right here in the denominator 3 squared. 3 squared, 3 times 3 is 9 in this denominator. This denominator here has a 3. 9 over here times 3 here gives me a denominator of 27. In terms of numbers in the numerator, it's just a 1, and then there is a pi. So I'm using pi over 27 as my numerical coefficient. Here in the numerator, I have h times h, which is h squared, times another h. So this is h cubed. So I've just cleaned up that whole equation to look like this. Now that I have a volume equation in terms of h, and we know dv, and we're trying to find dv dt, and we're trying to find dh dt. So now we're ready to differentiate. The derivative of v, dv dt. The derivative of pi over 27 h squared. So take the 3 out front. 3 times pi over 27. Well, 3/27 reduces to 1/9. So pi over 9. Subtract 1 from the exponent. H squared. And don't forget times dh dt. At this point, we're ready to try and find dh dt when h equals 3. I'm going to do this reverse of what I did in the previous examples, where I'm just going to go ahead and fill stuff in and then solve. So if I fill this in equation, dv dt, we are given to as -1. Pi over 9 stays pi over 9. H squared. We're trying to find dh dt when h equals 3. So 3 squared times dh dt, which I'm trying to find. Clean up. -1 equals, well, 3 squared is 9. 9 times pi over 9. The 9's will cancel, and I'll have pi times dh dt. To solve for dh dt, divide by the pi. And so I'm going to have dh dt is -1 divided by pi. Yes, there's a decimal. I don't know what the decimal is offhand, but I'd be fine with this. For label, it's dh dt, so it's a change in height over change in time. My height was measured in centimeters, my time in minutes. So this is centimeters per minute. So there's an example of a equation that has two variables that you have to work to adjust. Okay, and lastly, example 4. Example 4. Air is pumped into a spherical hot air balloon at a rate of 25 cubic feet per minute. Find the rate of change of the surface area of the sphere when the radius is 5 feet. So my shape that I'm drawing a picture of is a sphere, which, okay, I don't draw spheres, so I'll draw a circle. Air is pumped into a spherical hot air balloon at a rate of 25 cubic feet per minute. So if air is pumped into this balloon at 25 cubic feet per minute, again, what is that that's changing? You have to realize cubic means it's the volume that's changing. So dV dt is 25 cubic feet, so feet cubed per minute. And it's pumped into it, so it's a positive. Find the rate of change of the surface area. So they're asking me to find dA dt when the radius is 5 feet. Okay, so that's the information I'm given. Over here was my picture of a sphere. I just drew a circle, but it's good enough. And when you think about a sphere, we usually just talk about the radius. So I'll draw a radius in there. Now, this is a little bit different problem as well. You'll notice they give me dV dt. They want me to find dA dt. So they're giving me volume information, but want me to find area information. And what you have to realize, so we're going to have to use both formulas here and make them work together. So first of all, surface area of a sphere. Do we remember the formula? Formula for surface area of a sphere is A equals pi r, dang it, I forgot the 4. It's supposed to say A equals 4 pi r squared, but I forgot what I was doing momentarily. So let me adjust here. So, surface area, 4 pi r squared. And then while we're at it, I'll go ahead and talk volume. And volume of a sphere is 4/3 pi r cubed. Okay. They both have one variable in them. Because we need to talk dV dt and dA dt, we're going to have to differentiate both of them. Let's start by differentiating area. The derivative of area is 1 dA dt equals derivative of 4 pi r squared. Multiply the 2 out front, so it's 8 pi r, subtract 1 for the exponent, and then times dr dt. So as you look at that, dA dt is what I need to find. And we know 8, we know pi. We don't know r. Well, no, I take that back. We will know r because we want to find r equals 5. We don't know dr dt. And that's where we have to use our volume information. So let's go over and differentiate volume. The derivative of v, 1 dV dt equals derivative of 4/3 pi r cubed. 3 times the 4/3 means the 3 cancels, and I have 4 pi r, take 1 from the exponent, squared, times the derivative of r, which is dr dt. So now, use your given information. We were given that dV dt is 25 equals 4 pi. When we're trying to find dA dt, r is 5. So this is 5 squared times dr dt. And so now the advantage of this is I can use this equation to find dr dt. So 25 equals, let's see, 5 squared is 25 times 4 is 100 times pi, so 100 pi times dr dt. If I'm trying to solve for dr dt, I'm going to divide by 100 pi. So 25 divided by 100 pi. 25 divided by 100 is going to reduce to be 1/4, and then pi is in the denominator. So it's going dr dt is going to be 1 over 4 pi. And that is what we're going to use to substitute in up here to dr dt. So I'm now ready to finish finding dA dt. dA dt is 8 pi r, which at this point is 5, times dr dt, which is 1 over 4 pi. Do some cleanup. And, sorry guys, I'm a little off the bottom of the screen there, aren't I? dA dt. I see that my pi's cancel. 4 and 8 both divide by 4. So 4 pi is gone. 8 divided by 4 is 2. 2 times 5 is 10 times the 1. And so we are at 10. This is the change in area. Area is feet squared. So this is 10 square feet per minute. Okay. Hopefully that gives you a little bit of information to attempt the problems in homework. We will definitely have to go over an example or two in class after break. So, good use of your time, and hopefully you guys can get the homework done.